This video chapter will show you a variety of techniques to monitor for the presence of errors. Error monitors can be useful to alert you to a problem so that you can take a particular form of action. Actions might include triggering custom error mitigation or memory scrubbing. Error monitors can be tapped to drive off-chip software-based error mitigation or on-chip mitigation strategies. In some cases, you may also want to gather statistics on how often your chip fails, mean time to failure statistics, for example, or data on the modes of failure. Error monitors allow you to do this too. To create an error monitor, you'll first want to create an error flag, a signal that tells you that an error has occurred. Simplify Premier's duplicate with compare, TMR and safe FSM synthesis capabilities all come with the ability to create an additional error flag. The error is then monitored from a top-level port or via user-instantiated error monitoring IP. When creating an error monitor port or wire, be sure to preserve it so that synthesis does not optimize away the port during synthesis. Here's an example of how to monitor for the presence of an error in a finite state machine state register. A synthesis attribute is first used to create the FSM's error flag, and then another command is used to connect the error flag to, in this case, the port of some error monitoring IP. Here are some examples of how to create some error monitors. On the left is an example of how to create an error flag that tells you that an error was detected in a TMR circuit. On the right, an example of an error flag that monitors an ECC RAM for errors. You'll note an add-on set of circuitry that creates the error flag. In this case, an XOR comparator circuit. The monitors are created using a combination of attributes and commands, as shown in the example. Here's a live example of what actual DTMR circuitry looks like when you add error monitoring circuitry to it. You can think of the error monitoring flag created as an add-on to the DTMR circuitry that was put in place to correct the error. What's happening is that Simplify Premier automates the creation of the error flags that indicate that an SEU occurred, as well as automating the creation of the DTMR circuitry that corrects the error. This example shows how to tap an error when it occurs in an ECC RAM primitive. You could create error flags on almost any signal in your circuit using a capability called Duplicate with Compare, available in Simplify Premier. Duplicate with Compare creates two identical copies of the circuit, compares the outputs, and, if the outputs differ, generates an error flag that alerts you to the problem. A synthesis attribute tells Simplify Premier where you would like this to occur. Duplicate with Compare is cheaper than TMR in terms of area consumed, but unlike TMR, it does not correct single-bit errors. For Duplicate with Compare error monitors, separate circuitry must be created to fix the problem. Here is an example of using Duplicate with Compare to both detect and drive correction of multiple errors within an embedded system. In this example, an ARM-based subsystem on a Xilinx Zinc 7000 chip. Outputs from modules A and B are both being monitored, and so both of these modules are duplicated and an error flag created for each, error flag A and error flag B. The Duplicate with Compare error flags from A and B capture their individual error conditions, and we store them in an FPGA register bank. An error gets stored in the register bank when the outputs of module A duplicates A0 and A1 don't match, for example. The system software stacks access these registers to drive upper-level layers within the software stacks, causing actions that include error logging, error messaging, and of course error mitigation and recovery. For more information or to discuss or evaluate functional safety solutions from Synopsys, visit synopsys.com/FPGA safety, or feel free to view the additional videos in this video series.